We're not doing this just for some tech accomplishment, but we're doing it to solve the challenges of people and planet.
The thing that had been the AI test forever just went whooshing by.
We've increased the energy efficiency of computing by 10,000 times.
Today, we're launching GPT-5.
Gemini 3,
Llama 4,
Claude, Grok 4.
It's the worst it'll ever be.
Yeah, buddy. Who doesn't like a good hype reel? All
Good
right.
morning.
Welcome to the Future Live. New name, new brand, new everything, new hype reel. Today is Friday, March 6th, 2026. I am Matt Berman.
I'm Nick Wentz.
And today we have a fantastic show for you. Super excited. We have three guests: Vinay Perneti, VP of Engineering at Augment Code; Illia Polosukhin, I hope I got that right, co-founder of the Near protocol, also co-author of a little paper called Attention is All You Need; and Chris Lattner, CEO of Modular. And if you're watching the show, please give us a like, subscribe. It helps us, gets the word out there, promotes the show. Really appreciate it. And I think we should talk about a little bit of news because a lot happened this week.
It's been a very busy week indeed. Alex, if you wouldn't mind sharing the old screen. First story we're going to talk about is, of course, GPT 5.4. So OpenAI released the Thinking and Pro versions. They're rolling out on ChatGPT right now. Also available in the API and Codex. And so pretty impressive benchmarks all around. Matt, I know you've had a chance to test around with 5.4. What are your initial reactions?
Yeah, I mean, I put out a video about this, but really this is OpenAI's answer to Anthropic's Opus 4.6 model. The Opus 4.6 model is still fantastic, but it's this model that is an everything model. It has world knowledge, logic, reasoning, and also importantly is incredibly good at coding. Now, OpenAI had two separate models for that. They had the GPT 5.2 model, and then they had Codex 5.3. The Codex was for coding, 5.2 was more for general usage, and now they had a baby, and that is what 5.4 is. And it is a very, very good model. I'm still testing it, still trying to figure out what I like, what I don't like, how to use it. But so far, so good. It is a very, very good model, and it just is very clear that OpenAI has figured out their pre-training, and now they're just pumping out models, and really Anthropic and them are just leapfrogging each other every other week, it seems.
Yeah, it's moving quickly. The consolidation of the model lineup, Codex, Thinking, General Purpose, makes a lot of sense for a lot of reasons, specifically for the enterprise. You know, these enterprise buyers don't want to be figuring out which model is the best. They kind of want an all-in-one package. So do you think this has anything to do with enterprise push, or is it less about the enterprise and more about just the simplification of the models in general?
I think it's actually both. This model is definitely targeted towards knowledge workers. I feel like the last few model releases from both Anthropic and OpenAI have been particularly aimed at knowledge workers. They're really good at agentic use. They're really good at tool calls. They're really good at PowerPoint and Excel and All of these things are very meaningful. And so you need the world knowledge, you need the agentic ability, you need the tool calling, you need the coding, you need it all in one package to really be able to excel at knowledge work. And that's what they did.
Yeah, I also read that, it's funny, we don't talk about hallucinations very often, but apparently there was a large reduction in hallucinations with this new model. So GPT 5.4 was 33% less likely to make errors in individual claims compared to GPT 5.2, and overall responses were 18% less likely to contain errors. So we're still fixing the hallucination problem. Sounds like they're making headway on that.
Yeah, I mean, look, these are non-deterministic systems. They are always going to hallucinate in some way. I like compared to where we were even 12 months ago, the amount of hallucinations is a fraction of what it was. So, but for the amount we use it here at Forward Future, we still catch it hallucinating at times, and you just have to be mindful. It's just like a human. Humans make stuff up, and so do models.
Yeah. Now, I saw a take online. I want to get your opinion on this. So some people are saying that they expedited this launch a little bit, and it wasn't just about the technical progress that they had made, but it was a little bit about PR. So obviously, there's been a lot in the news recently. OpenAI reportedly has lost some users recently due to some decisions. Do you think this is maybe a ploy to kind of get beyond that news and start talking about something else?
Maybe I thought we were going to talk about Minecraft, and now I feel like it's one of those. We're pulling like a Gen Z distraction play here, where Subway Surfer on top of something really serious. No, I don't think so. Look, these models are not something that gets baked and deployed in a matter of days. They've been working on this for a while. They probably have some kind of release schedule. Maybe they moved it up slightly, but I don't think so. I don't know. It would be speculation for me to say.
We don't often entertain the conspiracy theories here on the
I mean,
Future
maybe
Live,
we should. We should have
once in a while.
conspiracy corner.
Yeah.
Just make shit up.
Yu Chen Jin had a great tweet here. Overthinking model, a simple hi cost me $80. I assume this is a rare experience, but a funny one nonetheless.
Yeah.
All right, let's get to one more story before we bring on our first guest. I want to talk about Apple a little bit more broadly than these recent announcements. So let me actually move on to this next story, or this next tweet.
Yeah.
So Apple's CapEx strategy is either a lucky accident, right? Or it's one of the smartest moves we've seen. Amazon, Microsoft, Meta, Google are all spending enormous amounts of money, plowing this money into data centers. And meanwhile, Apple's on the sidelines, just letting it unfold. And we're seeing this play out in Apple stock too, which is looking quite strong. Investors are seemingly very happy that they're not investing all this CapEx. So what's your take? I mean, are they well positioned here, or are they missing out on one of the greatest technological innovations the world has ever seen?
So for a long time, I was just thinking Apple was asleep at the wheel. But I've been kicking around an idea, and it's very much in line here. So I mean, I think just a few days ago, Satya Nadella, CEO of Microsoft, said, by the way, Microsoft is pulling back on their CapEx spend, but he basically said all of the CapEx spend is a huge dice roll because maybe there's some innovation that happens either at the software efficiency layer, at the chip layer, that allows these models to be trained and deployed much more efficiently. And I'm not so sure about that, but the other thing that happens in parallel is your phone, your Mac, your Mac desktop, your MacBook Air, these things are getting better. The chips are getting better. The models are getting smaller, better, faster. And more use cases are going to be able to be accomplished on your local device. And so there's probably this future in which there's a very much a hybrid approach between cloud-based models, frontier models, large, huge, can't run them locally, and then also what you can run on your phone. But the percentage of use cases for the average person that can be run locally is increasing every single day. And so Apple's incredibly well positioned uh, for that. Now, these are just ideas I'm kicking around. I'm still thinking through whether like that is what I truly believe, but like there's definitely a steel man to be made here.
Yeah. I must admit, I've been a little bit of a hater, and I think I'm coming around as well. There's a few things really playing to their advantage here, like being able to sit back on the sidelines and pick the winners instead of racing against them.
Yeah.
It is going to be hugely beneficial for them.
Historically, that has been the Apple strategy.
And that's the Apple strategy.
Yeah.
And then in addition to that, I think the hardware moat is actually very underrated. So I don't know what the numbers are exactly, but I have to imagine the AirPods market share is north of 25%, maybe even more. So that's, millions, hundreds of millions of ears that you have access to. And I know you and I are both big believers in, voice form factor for AI.
Yeah.
And so again, their hardware advantage plays very well here.
Yeah. So
yeah, we'll
like
see.
the flip side to it is they're not building out the cloud inference layer. They're going to be forever dependent on Google or whoever else they're partnering with, and they're just completely missing the train. And use cases get more complex, they get more sophisticated, they need more tokens, not only more tokens, but better tokens, more expensive tokens, and they're just not going to be there for that. And so they're going to be relying on their partners, and maybe they're okay with that. But I think the straw man is they are missing the train, and as AI use cases continue to explode, more demand for tokens, and they're just not going to be able to keep up and serve the tokens necessary. Even if their local chips, the M5, M6, M7, they continue to get better, they're not going to get better as quickly, and they're not going to be able to host the best models as what the kind of NVIDIA data centers can do.
Yeah. People also talk a lot about their war chest. I think they have over $100 billion in cash. And so I think money can obviously buy your way into innovation, whether it's through acquisition or by other means. I think where that potentially falls flat as an advantage is, to your point, you see all these other companies race ahead in terms of capability. And, once Anthropic and OpenAI and XAI and all these other AI companies become more valuable, it's going to be harder and harder to buy them. So they're going to have to set their targets on something much smaller, and maybe they'll be so far behind that it won't matter.
I've seen a lot of talk that Apple should buy Anthropic, and that would make absolute sense, but there's a very small window in which they would even be able to do that. I'm sure Dario is not looking to sell, not looking to be acquired, but that would be a pretty cool partnership.
I agree.
This is good.
I had to pull this one up. Why not?
Sure.
Yeah.
Sit back.
Just a dude who invests.
Let's you want to bring on our first guest?
Yeah, we can always come back to stories later in the show. Let's bring on our first guest.
Cool.
So, our first guest leads engineering at one of the hottest AI coding startups, Augment Code. We're going to talk about this, but they're betting on the best context, coding agents that understand your code base. That's what's going to win. So, Vinay, welcome to the show. Please come on board here. How are you?
I'm good. Thanks, Nick and Matthew. Happy to be here.
Nice to meet you. Is it Vinay or Vinay?
Vinay, but either work.
All right, good. We want to get it right. But welcome to the show. Thanks for joining us.
Happy to be here.
So I suppose we can just start off with, for the people who don't know, what does Augment do, and why is it different from the cursors and the co-pilots and the rest of the AI coding tools out there?
Yeah, great question. So Augment's been around for almost 3 years now. This is even before pre-ChatGPT. And we were founded as a research lab with a focus on solving the software engineering problem, right? So we knew that models will get better, but context as a would be the biggest problem. So our first year was all about managing context and making sure that context, the right kind of context, is available to agents. We've since been very much focused on building software agents for professional software teams that deeply understand both the code base and the surrounding context around the code base. One thing I'll say, Nick, I think we might touch on this today. I think the world of AI is moving really fast, right? So we had to reinvent our entire portfolio going into this year to be completely agent first. One thing I think it's become clear to me is the future is small teams of engineers working with large teams of agents. And the tooling that we have today does not meet that world, right? It does not serve the folks that are operating in that world. So we reimagining the whole thing. The first of that is Intent. We just launched an app called Intent in beta a couple of weeks ago. Very positive feedback. The core premise shift there is you're no longer working in the IDE. You're starting with an intent and you're working with a team of agents to get that done. And then we are taking that to the next step that's actively working on to be an agentic platform. So yeah, super excited.
Vinay, it seems like this is where, like, as I see the evolution of different IDEs, including Augment Code, it just seems like the software developers being abstracted away further and further from actually reading the code line by line. Like, won't that cause problems if we're just not fully understanding what the code is doing? Like, how do you actually solve that?
Yeah, it's a great question because that's something that we think about a lot at Augment, right? Meaning we are fully AI native in that like I would say, a big chunk of our code is being written by agents. I think there's a few things that need to change as we think about how we approach software development. One, architecture and starting with the right design principles and guardrails is now even more important than ever. So starting with that as a starting point, and then verification, right? I think you need to invest a lot more in verification to make sure that the your intended outcome is actually what's happening on in reality. And then the details, I think, are the ones that we don't. It's sort of like I think the parallel that comes to mind is we don't look at assembly today, right? We take that for granted and we say, yeah, the compiler is going to produce the right translation from code, and we trust the outcomes. I think you'd be moving one level higher with sort of the coding agents and models that are coming together.
Yeah, I think maybe the counter argument to that is if you're like, yeah, we're definitely not reading binary, but every abstraction above that is deterministic. But at the new layer, it's non-deterministic. So the natural language we're putting into the model can create different versions of code, different approaches, even if you're using, Opus versus, GPT 5.4, whatever you're using, it could be very different. So how do you think about that?
Very true. I think that's where verification plays a big role, right? I think as you're, in the Intent app, for example, that we launched, there is an exclusive verification agent which ensures that whatever the intent of what the developer is trying to do is actually what has been implemented. That's still an area of research. We are continuously improving how we can make the verification loop super tight, but that's how I see us going forward.
Can you actually walk us through how verification works at Augment in practice? What are the methods that have found most effective? What are you experimenting with but may have not implemented yet?
Yeah, I mean, in terms of the general software engineering practices, we have all of those, right? I'll maybe pop with the higher level and then go one layer down. We have a CI/CD pipeline. There's multiple stages of tests. Starts with unit testing and then systems testing, and then we have feature flags to roll things back, canaries. We have all of those built in, and I think those will become. It's no longer like an optional thing. You have to have an engineering pipeline that is very robust. That's one. But let me talk about the day-to-day from an engineering point of view. I think the way that is shifting is we've been pretty public about this. We are completely going spec-driven, right? All of like the team that's working on the next generation platform, they're all interacting with each other in specs. The humans are aligning with each other on specs, and there's different layers of specs. And once the humans have aligned on, I mean, this is a pretty complex platform, right? So it's not like one person has it all like completely in their head. So we have like a hierarchy of specs where like, the broader shape of the platform, what are the different components, and then they have specs individually. And then you take those specs and then you're working with an agent to further refine that to an implementation spec. That's one flow. But as part of that, it's no longer that verification comes later. You're doing that as part of implementing the spec. Again, I go back to intent as a product. The product itself has verification built into it, right? So you have a spec, and you're going from, okay, this is the spec, and the verification loop is verifying the spec is implemented. And then the next layer of verification starts rolling in as the CI/CD pipeline kicks in.
Interesting. So I actually want to talk about the human side of all of this. You mentioned Augment is going agent first. Brian Armstrong famously said that he would fire engineers that weren't using AI tools, gave them a week, and then kind of showed them the door, right? Like, walk us through how does this happen in an organization like yours, where you're encouraging everyone to be using these tools agent first? As a manager, how do you do that?
Yeah, it's a great question. I've always thought Augment as being fully AI native, and beginning of January, it actually occurred to me we were not AI native enough, right? And here is kind of what I mean by that. I wrote a blog about this. One of my favorite questions to ask is like in my one-on-ones, I ask the team like, "Hey, how are you using agents? What's been different?" And when I came back from my winter break and I was chatting with the team, something significantly shifted. Like in January, I could tell that a number of folks basically said, I'm no longer writing code. These are senior ICs, staff plus level ICs that are incredibly productive. They've been around the block for 20 plus years, but all of them independently have come to the conclusion that I can no longer keep up with Opus 4.6, Codex 5.3, because they're not only producing high quality code, they are finding themselves operating on multiple areas of the code base where they would previously not venture into, right? So that was like a big aha moment for me. Meaning, when people say AI native, I think there's a huge spectrum there. Some people think they're AI native if you're using code completions. Most people think they're AI native if you're using agents in the IDE. I would actually argue that's not being AI native enough, right? AI native is you're going all in on agents. And this is where it gets uncomfortable. Agents are not completely 100% there yet. But if you believe you're in an exponential, like I was meeting with one of the researchers at Anthropic, and they were basically telling us that it's no longer a hypothetical. It's pretty clear that we're going to be 10x in terms of agent capability by end of this year. And by 10x, that means agents can do 10x longer tasks than they're able to do right now.
Wow.
Just sit with that for a moment, right? Like agents can do much, much more complex things for much longer. So going back to the human question, so I had to stop and then say, like, hey team, we're actually not AI native enough. And that led to a number of uncomfortable sort of discussions because, wait, what does that mean? Like, what does my role look like as a software engineer? Who's doing the code review? How do we make sure we're not shipping a bunch of slop, right? So one of the things we did, I'm a huge believer that, if folks have the right mental models, they will do the right thing. And if I'm having this debate, that means we don't have the right mental model. So we actually spent 2 days like on an offsite for the whole engineering team. The first day was a hackathon, and for the hackathon, we actually structured it pretty simply. We said you cannot write code for this hackathon. You have to use agents. Everything you're producing for this hackathon is agents only. And I mean, Augie, we have our own CLI agent. It's fantastic with code base awareness. That's the only thing you can use. And the themes for hackathon were how can you 10x your own agent? Because like agents, it turns out they still need access, right? Like, I mean, if it's painful for them to set up a dev VM to go do their testing, they can't be as effective as a human. So how can you 10x your agent? How can you 10x your team? And how can you 10x yourself? That's it. Three themes and build whatever you can with agents. I was blown away by how much the team like produced in literally one day, right? That's the power of agents. Everybody like sort of push the boundaries of like what is possible because of us creating the space. And then, I opened the hackathon by saying, look, what are the emotions everybody's sitting with in this room? And it was pretty clear, like a number of like the word cloud, it was an anonymous word cloud on the screen that everybody could see live. Big, bold, uncertain, frustration, fear, right? And this is a team that is like at the tip of the spear, if you will.
Sure.
And alongside, there's a lot of curiosity, agency, freedom, right? Creativity, like those are all the things that came up. So this is the mix of emotions I think everybody's going through. And then for the remaining half of the day, to answer your question of like, how are you navigating it? I flipped this back on the team. I told the team, I don't know how to navigate this world, right? Like, I don't think anybody knows. There's no playbook for this. But I believe that this team can figure it out. So we got into breakouts and we did two breakout sessions. One of them was what additional tooling do we need to build to make sure that we can be fully agent first? And the second one was what human behaviors do we need to change? And I was blown away by what the team came up with, right? This is not me. I didn't come up with this. The team came up with, like on the human side, for example, the team came up with and said, hey, we need to invest more energy in making sure that our agents.md and skills.md are very high quality. Let's actually go spend the time doing that. We need to be fully spec first. Let's talk about what that means. What does good look like? How do we get like there's a new muscle, right? And think yeah, and I could go on for much longer, but that's kind of how we have been approaching this particular transition.
Vinay, at a certain point, like just getting into the nitty gritty about it, like if agents are producing so much code, there's only so much humans can review on the other side. So like how are you thinking about that? And it's only going to increase from here. If we're talking about agents be able to run 10x longer, how do you 10x your team? How do you 10 like these are actually like likely to happen by the end of the year. How do you actually review all of that code and make sure you're not just shipping things that you and your team don't understand?
Yeah, great question. So this was actually a topic that we dug pretty deep into at the offsite, and a couple of insights came out of that. One of them is today every single pull request is reviewed by humans, and the entirety of it is reviewed, right? That doesn't need to be that way. Agents are actually quite good at catching a lot of the issues. We have a code review product that is super high quality. So the code review team pivoted their product. So the code review product, when we built it, it was built for humans. And we actually prioritized precision over recall. Why? Because we wanted to make sure that the humans that are reviewing want high signals, right? But if your agents are reviewing your code, you actually want a lot of like you want to catch all the bugs. So we are pivoting our code review product actively right now as we speak to say, look, 80% of the code is going to get reviewed by agents, and the agents are going to like highlight maybe 10 to 20% of the code changes that require human intervention. But eventually, like maybe 6 months from now, that might become much smaller. Maybe 1 to 2% of the code gets reviewed by humans. But that's the journey that we are building, right? And we see that bottleneck already, by the way. Matthew, I think you're spot on. Like the team that's doing very spec first way of building, they're like, yeah, we are hitting this roadblock on code reviews. That's one thing that we're actively solving.
Yeah, it's super interesting. And then as your ability to produce a lot of code, and let's just assume it's going to be high quality code end to end, and you're able to review more, how does that actually affect like the structure of your team? Are you still hiring? Are you hiring less? Like, what does that actually look like?
Yeah, I don't have a fully formed answer, but I'll tell you what we're doing. So we actually paused hiring just for a little bit to regroup ourselves as to what AI native hiring looks like. And in fact, just yesterday we had an offsite with a small group of people thinking deeply from first principles. What does it mean to be an excellent engineer in this AI native world? And what are some of the dimensions that would become more important, and what are some dimensions that become less important? We'll make a blog post probably in a week or two, but that's kind of how we are approaching it. Like we're pausing a little bit to rethink from first principles and then resume hiring.
Curious to get any highlights. What does make a good engineer in this AI
Yeah,
first future?
I think there's a few dimensions that stood out. Like we talked about the importance of systems and architectural taste as an example is something that would still be valuable. We talked about product taste as something that still continues to be valuable. The team
What is
added.
I'm curious what you think product taste means in this context. We talk about taste a lot. Both big believers that taste is going to be important in many industries. Is it about understanding the customer needs kind of inherently? Is it about forming taste through customer conversations, seeing what's happening in the market, building your product accordingly? What does taste mean for an engineer?
I think it's that, and to me, I think uh, you know, for better or worse, when things were very complex, right? PMs were predominantly thinking about product, and engineers were predominantly operating at the task level. I think that can no longer be true going forward, right? You have to pop up one level higher to be very much about outcome-oriented thinking and impact-oriented thinking. We think about that a lot at Augment. Like, when I was at Meta, that was all about like impact-oriented thinking. Like, what is the impact of your work? Sure, you produced a 1,000-line PR, but what is the actual user impact that particular piece of work had? And taste becomes an important part of it, right? Like, sure, I created this new surface in my product, but nobody used it. I would have to go figure out why are nobody using it, what's going on. Like, and I think that's a part of developing the taste, and part of that is like owning things end to end, being more outcome oriented, a lot more user empathy, as an example. I think is something that we'll have to develop. Those are some of the things that surfaced.
Vinay, I'm hearing a lot of the same things you mentioned earlier. There is a lot of fear and uncertainty, especially in the knowledge worker community, especially in the software developer community. And so when, you said Augment paused hiring, I'm sure that is driving, or at least people are reacting to that pretty strongly. Maybe you can clarify, do you plan on hiring again? Are you just trying to figure out what the right archetype of an agent-based engineer looks like? Or do you think you could just continue growing with the exact team you have today?
To me, so I'll say a couple of thoughts. We definitely plan to reopen hiring. Certainly the plan right now. The thing I'll say is the world is moving so fast. I in fact told the board that I don't have an end of the year like headcount plan for you. Like, don't expect me to give you something that'll basically pass muster, right? Because when you're in an exponential, the rate of change is so fast, it's hard to know like what's coming 6 months down the road. So the main reason why we paused is mostly to like hang on. Inertia is very strong, right? Like if you're going down a path, you just want to keep going down that path. We wanted to create that tension to say, no, we have to figure out what AI native hiring looks like, and then let's like get the right team so that we can ride the next wave. That's kind of how we are approaching it right now.
Yeah. It's pretty interesting how quickly the concept of yearly planning has evaporated.
Oh
It's
yeah.
just impossible. I remember spending weeks on end planning for the next fiscal year. And now, is anyone doing that anymore? I can't imagine it's possible.
Yeah, I mean, it's funny you say that, Nick. Like, this was last year, 2025. At the beginning of the year, we actually had a yearly plan. Jan 25th, we threw the whole plan away. And we're like, I guess we're building agents. And then we
Yeah.
like that's when we built it. And this year, I didn't even attempt to do an yearly plan. I told the team, we have a
What's the point?
vision. We have a vision of where we are going, but the plan is 3 months. Like, that's the thing that we're executing towards. That's kind of
Gotcha.
Vinay, you totally reminded me of that meme of there's like the factory printing thing, and then all of a sudden they go, I guess we're building agents.
yeah.
That's totally look. I appreciate the honesty on the hiring front, and I think different engineering leaders have different thoughts on this, but it seems to hit every area of the spectrum of I'm hiring more than ever and I can't get enough, to uncertainty, to no, we don't need any more people. So and you're right, everything is so dynamic. It's going to be fascinating to see how this all plays out.
Yeah.
Yeah, for sure. Yeah.
The so the I want to talk about exponentials actually in a second. You hear lots of people talking about them, saying that it's impossible to understand them. humans are inherently flawed in trying to grok exactly what an exponential actually feels like. How do you like? What do you make of this phenomenon? Like, if we're on the exponential right now, how can we help the average person understand the impact of that, or what that experience is actually going to result in?
It's funny. I think humans make sense through stories, right? Like I have a 6-year-old, and I told my entire company a story about like my son. It so happened that I read a book for him that explains an exponential, and the way I'll do a short version of it because I think when people say exponential, like they hear it, they don't actually register it. And the
Yes.
power of compounding, right? Like the TLDR of the story is a king basically grants someone in their kingdom a gift. They're like, you can ask me whatever you want, right? And this person says, okay, give me 1 grain of rice today,
Hmm.
and then 2 grains of rice tomorrow for 30 days. The king is like, sure, that doesn't seem like too much. I'm happy to give you that wish. And as you track the progress of this exponential, like you'll pretty quickly see there's 2 phases of an exponential. There's the linear phase, which looks like, oh, there's not a whole lot happening, right? So 1 grain becomes 1,000 grains by end of 10 days, 1,000 grains becomes 1 million grains by end of 20 days, and then by the end of 30 days, it's 1 billion grains of rice, right? And you pretty much ran out of all the rice that the kingdom had. This is, I think, what fundamentally is super hard about exponentials. Like at the beginning, everybody thinks, oh, no big deal. But then before you know it, you're like, holy crap, what is going on here? Like, this is not something we can catch. And the way I bring this back to software engineering is, it's hard to be literally a year ago, right? Like back in Jan 2025, they were bare like the term software agent was like very novel, very new. Maybe like Cursor had like a sort of early signs of an agent in an IDE. But if you look at it right now, this is 12 months, right? Like we're not talking
Yeah.
about 5 years. This is 12 months. And my team is fully on agents. And you probably saw Andre Karpathy quote on X about saying his for him it shifted where he's writing 80% of the code with agents. Greg Brockman from OpenAI mentioned that a majority of his team is writing with agents. Just think about that for a second. Like this thing did exist 12 months ago, and now we are seeing a number of forward-leaning engineers are writing their like entire production quality code with agents. Fast forward that a year from now, I think it's going to be small teams of engineers working with large teams of agents, working on real high-quality production code. I think that's kind of where we are heading.
All right, Vinay. Really appreciate you joining, talking to us about all this. Check Vinay out at Vinay Perneti on X, and of course, augmentcode.com. Go use it. It is great. Thanks for joining, Vinay. Appreciate it.
Yeah, thank you, Nick. Thank you, Matthew.
See ya. Yeah, I
Yeah.
mean, it's such a dynamic time right now, and I get such varied answers when I ask about hiring, when I ask about how they're thinking about even the next 12 months from engineers, engineering managers, knowledge work managers in general. It's just so wild right now, and uh, friend of the show Atlas, he said there's just like this pretty thick layer of anxiety over everybody in San Francisco. So it's just very interesting.
Yeah, his advice was to go touch grass, get out there. Uh, by the way, it's interesting that this tipping point happened for engineers where now they're relying on agents to write most of their code January, February this year. What's also happened is that non-engineers are writing code.
Yeah,
Like,
totally.
our entire team, anyone who's non-technical, like they're all writing software now.
Yeah.
So it seemed to be a tipping point for everyone.
Yeah, yeah. I think like it's probably a confluence of OpenClaw kind of capturing the imagination of a lot of folks who are not technical, and then also just the agent coding tools getting to that point where they're so good, and everybody feels empowered to build things, and it's awesome. I love it.
It's very exciting indeed.
Yeah.
We have some stuff coming out soon actually that was entirely built by agentic tools. Excited to share it soon. But before we do that, we have our next guest. He is a co-author on the now famous Attention is All You Need paper, which introduced the transformer, which paved the way for AI as we know it today. He is now building Near Protocol, betting that the next layer of the internet needs to be open and user-owned. Illia, great to have you on the show.
Thank you for having me.
Hey,
How are you doing
Illia.
today?
I'm doing pretty well.
I like the background. So give us the quick elevator pitch for Near Protocol.
So the core idea is we're gonna move to a world where everybody has their personal agent that's gonna do everything for them, as you guys were just discussing. This is, I think, went from a crazy idea to getting to become a reality. And there are a few things that we want in this world. One is we want the agent to be actually personal. So we want all your data, all kind of decisions to be on your behalf. We need it to be secure. But the other side is it needs to work with other agents. It needs to have a relationship with other people's agents, with other businesses' agents. And this is where the economy comes in, right? Economy is how do you manage resources, how do you satisfy everyone. And so we think of kind of the protocol part as really this neutral platform where all the agents can really collaborate in economic sense, right? Do commerce, figure out how to negotiate for resources, and dispute when it's not happening the way they expect. And then you have personal agents, user-owned AI, on your side that actually is secure, private, and aligned with you. So those are kind of two pieces that we are targeting, but we think of them as like a holistic kind of agentic commerce platform.
How long have you been building Near for?
So we actually started in 2017 after I left Google, working on transformers, because I thought that people should not write code. As you guys were just referring to, now everybody can just talk to computer. So I expected that to happen way sooner, and so I left and we started Near AI originally to teach machines to code. We had some interesting research, but it was too early, right? The hardware wasn't there, kind of the scale wasn't there. And while doing it, we realized we needed the economic platform to actually collaborate with other people around the world to do data labeling, to do data collection. And so we kind of decided to focus on the blockchain, get that going, and come back to AI after. We were a little bit excited, so we thought that we're going to finish it quickly. It took a few more years, but we brought it back and kind of have now this both components of blockchain as neutral platform and AI as effectively I call it AI as a front end, blockchain as a back end. That's kind of the, in a abstract way.
Yeah, it really does seem like the way, especially now with the explosion of agents and agents being able to do more on the human's behalf, the way that they're going to be able to negotiate, purchase, transact with other agents, even with other websites, seems to be through blockchain, crypto, like credit card processors. They don't want automated approvals. They still require a human in the loop. And so to really break that loop, you need a better protocol, and it does seem like crypto is the way.
Yeah, exactly. I think there is in crypto world, there was kind of a limited view that crypto is just the payment part, right? Like you move the some amount of units from one place to another. The reality is the commerce itself is a lot more complex, right? It starts with how do you find who to transact with, right? How do you negotiate what you're transacting on? How do you agree on the final outcome? Then, when you move money, how do you escrow? And if something goes wrong, right, the real world is unpredictable. How do you resolve that, right? And blockchain usually only handles this one piece, which is like move money from A to B. Now, it doesn't need to just be that. And so what we've developed, what we call kind of intent-based transactions, where you can specify the intent, right? Like I want this outcome. I want, some dollars for euro, or I want, 10,000 tons of steel delivered to LA port, right? I want, a website built, or I want a marketing campaign that generates, 100,000, conversions. Like that's an outcome. And now we have a whole system where you can find the counterparty, you can find agent or market maker or some other entity that will do that, and then there's a whole dispute process. If something goes wrong, there's actually agentic disputes, effectively agentic court that's embedded there. And so you can check out this on market.near.ai. It's kind of the agentic market where agents can hire each other. And then we also run in kind of more financial infrastructure like that as well for payments and trading. That's processed already $13 billion. Not .ai.
It's interesting. I feel like maybe in the AI world, crypto has gotten somewhat of a bad name because, when you look at Peter Steinberger, who created OpenClaw, he basically says if you even mention crypto, you can't be in our Discord. You can't I think there's a lot of bad actors in the crypto world. How do you get around that? Is it just like continue to build great product and deliver it and drive value? How do you avoid what seems to be a trap of a lot of malicious actors in the crypto world?
Yeah, I mean, I think this is definitely brings the crypto space down. The permissionless also means that the kind of the opportunity for crime is open. It's market.near.ai, by the way.
Yep.
I think the reality is, yeah, as you said, I think the quality wins in the long term. And then I think the benefit is like we are in crypto, we're kind of more like educated how to spot scams, and then in AI space, kind of they just got flooded by this. And so I totally understand where he's coming from because he got attacked by effectively a bunch of people, like from both sides, from people launching meme coins and doing all kinds of weird stuff, and then people who like kind of scamming the people, like using OpenClaw, etc. And so it's like easier for him to ban it and figure out how to do it properly. Obviously, we coming from blockchain space, we've been, I would say, curating kind of how people should approach this, and but it does take a lot of work and kind of knowledge how to navigate that properly. But I think our vision always been that blockchain, as I said, should be on the back end, right? It should be the background. You don't really think when you go to Netflix, you don't think like which cloud it uses. Like, is this I use in two different clouds, etc. Right? You just use it and it works. And blockchain should really be like that, right? So I mean, this market just again, this is an example, but of the same protocol, but it just looks like an app work for agents or service registry for agents. They come in, they use it, and it just like it uses crypto underneath, it uses the escrow system, it uses all the tech we built under the hood, but it just looks like a marketplace.
So this reputational issue, are you seeing this at all manifest in how adoption is working or even recruiting, or is it an overblown issue that isn't actually having an impact on the business today?
I would say like we're in a unique position because we do have deep AI background,
Yeah,
as well as like we've done a lot of kind of heavy duty like AI work. We're running a full AI infrastructure, in confidential compute from NVIDIA. We're running inference. We're running kind of agent hosting computing, build Ironclaw, kind of the agentic framework. So we don't have that challenge, but I think in general, yeah, the crypto right now is kind of in a little bit of existential crisis because AI is also just very exciting. And so there's a move for people just even go to AI from crypto because like more exciting. To me, it's the same thing. It's like, hey, it's not A or B, right? It's like, oh, I'm gonna only build front ends and not gonna build back ends. Like that's kind of what it sounds like.
Yeah.
I'm not gonna use databases because that's
yeah.
Illia, so you mentioned Ironclaw, and I want to come back to that in a moment. But I just like as somebody who was there at the moment, co-author of "Attention Is All You Need," which is the seminal paper that really kicked off this current generation of artificial intelligence. Like, while you were writing it, did you know what was going to come from that? Like, what was that like at that moment? And yeah, tell us a little bit about the story there.
for sure. Yeah. So I mean, the context was, I mean, I always kind of I think I was 14 when I thought like, hey, computers should just write code. like this is dumb that we need to, type in the code ourselves.
Ahead of the game.
And this was like 2004 or something like that. Now at that time, obviously nothing worked, right? And I was also in high school trying to figure out how the math works for all this stuff. But this was always I was always excited, and so when I was joining Google, I was really wanted to work on how to advance the AI understanding language, understanding logic, and so I joined a team that was specifically working on question answer, right? So how do you actually answer questions? The good thing is on Google, there's a ton of people asking questions all the time, so it's a great place to actually do that. And as a research, you actually try to, you try the methods to get the best results, but then you cannot actually put it into production, right? We had this like long short-term memory models, like recurrent neural networks, that really were too slow, right? You would give it, Wikipedia page, and it would take, 10, 20 seconds to read it, and then respond to a question. And obviously Google is like, hey, you have 200 milliseconds to respond, otherwise we're not integrating. And so we had another team kind of under the same director, Jakob, who was another co-author, and they were also doing like how do you scale kind of query similarity. So it was a lot of like natural language kind of reasoning, like AI research that really kind of culminated from the demand of the performance, from demand of like how do you actually consume lots of context really quickly. And the fact that we have these parallel processors like GPUs that actually can do that in one step, right? Like I usually for non-technical people, if they have watched movie Arrival, the way transformers work is kind of like and this is a spoiler, but the aliens are producing the whole sentence, right, in one go, right? And so transformers consume the whole sentence in one go, right? So like they can read the whole, paragraph page book in just one look. Right?
That's such a good analogy.
Great analogy.
Great
movie too.
A great movie, yes. Great book as well.
Yeah.
And the core idea is like because we have this massively parallel kind of compute, we can do that extremely quickly. And then the attention mechanism is what you need to really reconcile and make kind of understand how each word, each sentence is like what's its meaning in the context of the rest of the document, right? And you do that multiple times, right? So you kind of do this process multiple times to get better and better understanding, more and more reasoning steps. And so that was kind of the core idea. I mean, it obviously took a while to get it to work, but like the first version, kind of was an idea, hey, what if we don't actually read word by word, but read everything in parallel? Can this even work? And it kind of worked. And so then it took a bunch of experimentation and insight to get to state of the art. But I would say, like, from a perspective of that time, there was continuous change in model architecture. There was like probably 7 papers that were all trying to target this similar space of like, how do you actually deal with long context? How do you navigate it? How do you actually understand it? And so it wasn't clear immediately that this is the end. It felt like really massive progress, but we were kind of pumping out new architectures like every 6 months as like a research organization. And so that was, but it was clear that something has shifted, right? That's why I went to start Near AI. I thought actually we were like, yeah, we're actually now can train machines to code. Let me go do that. And I was a little bit early on the compute side, but the architecture was there.
Incredible.
That's incredible.
It's
great story.
Yeah, man, it must have been so wild to put that out, and then a scant 6 years later, change the world completely.
Yeah.
Okay, let's talk about Ironclaw, and I also want to talk about local AI, and because they almost go hand in hand. So first, what is Ironclaw? Obviously, it has the Claude name, but what makes it different from OpenClaw, or is it an extension? Tell us about that.
Yeah. So I think maybe to give you a mental model, I actually think these agentic harnesses are really the new operating system, right? So these agents will be how we interact with computing going forward. I think like actually browsers will disappear, apps will disappear. It will be just your agent. And this agent now is the operating system that runs on your computer that interacts with other services and APIs. And so you need to build it in that state, in that way. And so OpenClaw, great idea, great development. Obviously went viral, showcased what you can do, but it's kind of built in a very insecure manner, right? There is no kind of security isolation systems. It's written in kind of TypeScript. And so with IronClaw, what we try to do is like, okay, well, what if we take this operating system mindset, right, which is a lot of defense in depth, isolation, tools and modules need to be isolated and running in sandboxes, and bring this to the kind of OpenClaw style harness state. So really what this is your secure personal agent, personal assistant. It's a framework. You can install it locally, or we have the hosting, and we can talk about kind of our confidential hosting for it. But it is effectively defense in depth. So every single tool is isolated and runs in WebAssembly. This is something that every browser runs. This is something that we as blockchain been running for 7 years and spent a lot of effort hardening it and protecting against all the hacks, because it's actually protecting a lot of money. Has prompt injection detection. It has data exfiltration detection. Effectively, it has a control plane around all your credentials. Your credentials are fully encrypted and only get decrypted at a time of outbound when the policy checks passes. So to give you an example, if your Google account ID, it never hits LLM and it never can go to any non-Google domain. Right? So it literally just not allows to decrypt it if the URL is not Google. So things like that, right? It's like really kind of tying up all of these pieces and creating kind of secure system. It's written in Rust, so kind of a lot of just static analysis as well that is easy to do. So that's kind of the concept. We obviously, it started like 3 weeks ago, so there's a lot of work. Still, we have a bunch of contributors in open source who are coming in, which is super helpful, and we kind of keep expanding what it can do. But it has routines. It can do sub agents that are running kind of independently inside their own containers as well, so they cannot kind of affect each other or the main core. Gonna add a lot of exciting other features as well.
I wanna ask about local AI, and I want to ask this in two ways. I think OpenClaw allowed a lot of tinkerers out there to really run it locally, but then I think a lot of people are also exploring running the model locally. Do you think that is inevitable? We talked about that at the top of the show a little bit. I've been thinking about like how much is the average person really going to be running local models, and so what's your take on that?
Yeah, so I think in general people will not do that. And that's why actually we offer the confidential hosting. So what is confidential hosting? It's as if it was local, meaning there's nobody else who actually can access your data or your inference, but you get it always on, you get it, on modern hardware, and you get it, upgrades, etc. Like all of that is effectively set up, and it's isolated from your machine, right? So it definitely cannot also affect your setup. So that's our agentic hosting. If you go like agent.near.ai, I can log in and check it out. But I think for local, I mean, the benefit is for people who do want to tinker, it's kind of a great opportunity to play with it. And obviously the intelligence of the models who can fit locally is keep rising. We actually started Edge Intelligence Society back in 2023 because indeed it's a great opportunity for some things, and you can do interesting things where you effectively have this again some form of in-depth fallover, right, where it can use your local model for some things which are simpler, and then it can go back to maybe bigger models, at faster inference and scale that run in the cloud, but in confidential way for harder things or for things that you need running on background, right? I mean, for example, in my IronClaw, I have a ton of routines, right? Every morning it goes, reads a bunch of news, summarizes it, and pushes it to my channels, right? I have, get our GitHub, fetch all the latest commits and since the last version, create a change log, drop it prepare a tweet thread effectively about it, right? So like
Nice.
all those things, like you don't want to like my laptop is closed, right? You don't want to run it locally, like you want the cloud type setup, but all of this runs again fully confidentially, and we cannot actually access what's happening inside. So I think it's really about like creating this also handover between local and remote and cloud, and making that seamless. And again, that's why like operating system is really good, probably mindset for this, because yeah, like you want some of this to be local because kind of your operating system is local, but you also want this cloud backup. And like, I mean, Google Chrome may be a good analogy, right? Like you have some stuff locally, but mostly it's in the cloud. I think like that would be the again the framework.
So talk to us about some of these other use cases. What are your go-tos these days?
Well,
for OpenClaw or IronClaw rather.
Yeah. I mean, obviously, like because I'm developing it, it's the challenge when you're developing it. It's like you stumble upon a bug and then you go and fix it instead of actually using it. I noticed that myself. So I have like a hosted version where I actually use it, and I have like my local version is a complete mess of development. But yeah, I mean, a lot of it is like, yeah, kind of automating normal processes. And then because I mean, the way we structured is actually a lot of smaller companies that are kind of working together. So Near AI versus Near Intense for financial stuff, Near Protocol. So we have different notions and different kind of systems for that. So a lot of it also I do for effectively my kind of executive operations. So, give me like where we are on OKRs across all these companies. What are the bottlenecks? Where are the risks and potential kind of communications? What are the key decisions that are on deck? It like fetches all of this information from all of the different notions, really like synthesizes it. I actually then like put it back into a Notion doc that I can then share with like other executive team as well. So really kind of using it as like a kind of chief of staff type of role that has like this wide access to a lot of information, and then just a lot of like kind of routines that are running. And then I am coding a bunch now, so I use kind of this like sub agent system where I have like 5-7 agents running coding different features.
Yeah, it's interesting, the chief of staff analogy for OpenClaw, IronClaw. That's effectively how we're using it inside of our little company, Forward Future. So, Ilya, we're gonna have to compare notes one day on use cases. I would love to do that. But Ilya, I just want to say thank you so much for joining us today. It's been an absolute pleasure. Check out Ilya on X, IL Black Dragon, and near.org for the different companies that are under the Near umbrella. So, Ilya, thank you so much for joining us.
Thank you.
All right, thanks.
Talk to you soon.
Yeah,
that was fun. There was obviously there always is, but more to discuss. I'm especially interested in getting his take on the browser. Billions of people use the browser today, and if agents become the new operating system, it's going to be a big change.
Yeah, and it's funny because the browser is the biggest stumbling block for me with my OpenClaw implementation right now. It like effectively cannot browse the web. It cannot control the Chrome browser. I'm trying a bunch of different things right now. I'm setting up browser base actually. So we'll see. We'll see if it works. And we've talked about this internally. So obviously Ilya mentioned a bunch of work use cases for IronClaw, OpenClaw. I want more consumer use cases, but it's very difficult because a lot of the consumer use cases require a browser, and the browser it's so difficult for an agent to use because publishers don't want their content being scraped. So
yeah,
it's such a huge potential part of the market that is just completely blocked by a technology.
Yeah. Well, this is the decade of the agent, right? I'm assuming we'll see some progress. With that said, we have our final guest of the day. This is an individual who created LLVM in college, an open source technology now used by Apple, Google, Microsoft, and most of modern AI. At Apple, he built Swift. At Google, he worked on TensorFlow and custom AI chips. and in 2022, apparently very unsatisfied with only reshaping software a couple of times, he launched Modular. Chris, welcome to the show.
Hey, thank you for having me. Excited to be here.
Hey, Chris,
How you doing today?
Man, that's quite an
Good.
intro.
Good. Yeah, well, so I'm excited to be here. There's a lot going on. AI is such a fun and exciting place. So
Yeah, indeed. Actually, before we start talking about Modular and everything else going on in the market today, can you give us the quick story before or behind LLVM, how it came to be, why it's so widely used?
And what is it? What is it as
yeah,
well?
what is it? So underneath all computers are chips. And what LLVM is it's basically a way to make it so that you can talk to the chip without having to know all the details. And so you're abstracting over, in this case, CPUs, and making it so that you can talk to, Intel processors, ARM processors, other even goofier and weirder things as well, because people are always pushing the boundaries. And so LLVM, which is now 25 years old, crazy, started because there wasn't a really good way to do that. Back in the old days, there was the GNU compiler, GCC, legendary, very widely used, but it couldn't be used in certain situations like runtime compilation. And so if you have JavaScript and other things that you want to do at runtime, you don't want this like legacy batch, Unix compiler thing that you have to write everything in C. You want to be able to use it in different ways. And so what LLVM grew into is it grew into this platform that enables people to get performance out of chips. And so this is both for programming languages like Rust and Swift and Julia and all these modern languages all use LLVM, but it's also for things like the Snowflake database optimizer and query optimization and things like this, where you wouldn't think of that as something that you would use compilers for, but it turns out that you really do want performance. And so graphics, tons of different things all used LLVM. And as you say, it's widely used for lots and lots of different things. And across this journey, because it's open, what we were able to do is pull together hardware makers. And so getting Intel and AMD, or getting Apple and Google, getting all these different people that don't necessarily get along well on the product and business landscape to collaborate and build something that could actually scale that they could all benefit from was a big part of its ultimate success. And so LLVM today has been very useful for lots of people, and there's a big community, and it's been very exciting to see it grow.
So now you were a grad student, I believe, when you were working on this. So was this a research project turned open source project?
Yes. Yeah,
Okay.
very much. So this was my master's thesis project basically, and so
Wow.
kind of has grown from there.
How did it roll out? How did it gain adoption in the first place?
Yeah, so I graduated back in 2005. So it's been a few years now at this point, and joined Apple. And Apple at that point was getting more ambitious. This was before the iPhone, but it was after the iPod. And so they're no longer about to go out of business, but they were trying to up level all their technology base. And so they wanted to switch from PowerPC to Intel back in those days and things like this. And at the time, they had a lot of great capabilities, but they're always held back by the compiler technology. And so they wanted to do things like compile graphics code at runtime, right? Things like this. They wanted to have, it's very funny in today's lens, but they wanted to have, IDEs for coding that were very productive, and they wanted to have cool features for working with code. Again, 20 years ago, that was pre-AI, but you couldn't really do that with the technology of the day. And so I came in and I said, hey, I've got this thing. It's 5 years. It's been developed for 5 years. It's very promising, but it's still research. How about I join, and how about I make this relevant to Apple and invest in that? And because it started as a university project, Apple allowed it to be open source. And so I kind of had two roles, one of build and solve the key problems that Apple had, which I was quite good at, but also make sure to do so in a way that wasn't just completely specific to what Apple needed, and actually foster that community, pull folks in, make sure they could be successful and they could solve their problems as well.
What was it? Slight tangent. What was it like at Apple at that time, going through that huge transition into, obviously, like, maybe the younger kids don't realize Apple was kind of like looking at death at a certain point, and then a few things happened. Steve Jobs came back. What was it like at that time?
Yeah. Well, so I joined after the most perilous part of its journey. And so I was in it was an unattractive company that weirdos wanted to work at. So it was not the rocket ship. It was not taking off. Again, this was pre-iPhone. But they had really compelling products. And if you wanted and you aligned with the Apple value system of build really high quality things, work backwards from the user and the problem to solve, not forward just from the technology, then it was super appealing. And across the iPhone journey and things like this, the company transformed multiple times and struggled with growth, struggled with self-identity, struggled with, reorganizations and things like this. And so the thing I loved about it is that everybody was super hungry, and we always wanted to push the boundaries. We wanted, I helped drive a lot of the silicon transformation where Apple insourced its CPUs and its GPUs and all that kind of stuff. And other people drove the hardware, but I did the enabling software to make it so that we could ship the first 64-bit phone. And everybody was laughing at us. Why do you need 64 bits in a phone? That's silly and outrageous. But when it launched, it blew everybody away, and they stopped laughing. Right? And so that was super fun.
Yeah, now Apple obviously known for creating incredible silicon, incredible software, hardware, bring them all together. And possibly one of the best decisions to bring all the silicon in-house in corporate history at this point. So very interesting. Okay, Chris, let's switch topics. I want to talk about Mojo and Modular. Give us the high level. What are you building now?
Yeah, well, so before I do that, I'll tell you that it's so funny because everything that was happening 20 years ago is happening again. And history doesn't repeat itself, but it definitely rhymes. And so, 20 years ago, there was this huge diversity of different chips and systems, and it was all fragmented, and nobody could actually build unifying software onto this, right? And this is why you didn't have Rust or Julia or things like this springing up until LLVM came around. LLVM enabled scaling across a wide variety of chips and being able to get leverage across that hardware ecosystem. It also enabled a whole bunch of chip makers to be able to innovate in their silicon and move way faster because there was this kind of funnel point where you could actually, implement some new feature in your chip, implement an LLVM, and then the entire ecosystem would benefit from it. So today we have that problem, but for AI. And so you have chips coming out every, month, it feels like, from startups. We have the hyperscalers building incredible systems. We have NVIDIA that's continuing to push the boundaries, and they're definitely not slowing down. You have AMD and so many people that are all building chips. But so much of the software developer experience is still consolidated around NVIDIA. Like, lots of people want choice. They want the ability to scale across multiple different vendors. These chips have different trade-offs. Some are super low latency, or some are, designed for wearables or things like this. But right now it's just such a challenge to do that. And so app developers generally don't take advantage of all that silicon that's out there. And so what Modular was founded on just over 4 years ago is saying, let's crack this problem open. A lot of people have been talking about this. A lot of people want this. A lot of people want choice, whether it be the app developers or the AI innovators or the people that are doing crazy research. The hardware folks also want this because they want to be able to build chips that get bought, fundamentally. The hyperscaler, the cloud providers want this because they want new alternate silicon that they can deploy to have differentiation and scale and things like this. But nobody's been able to crack it. And the reason is it's really hard. There's been lots of systems, lots of attempts where people try to do a layer on top of PyTorch or TensorFlow or these kinds of systems. They try to do a 6-month sprint to go enable one use case. But the problems are much more profound than that. It does take years of research. It takes deep systems. It takes compilers. It takes programming language. It takes innovation at the AI framework level to actually help solve and scale these problems. And that's where Modular came from.
Okay, so if I understand correctly, you're allowing basically every segment of the AI market to abstract away from writing code directly to a specific chip. Very, very analogous to what you did previously.
That's right. And also analogous to Swift when, again, this is years ago now, what Swift did was it took, before Swift, if you're an iOS developer, you had to struggle with Objective-C. The apps that people were making were amazing, and it was incredible what the iPhone could do. But because Objective-C was so difficult to use, pointers, square brackets, weird legacy syntax from the 80s, it was just very difficult, and it really narrowed down the audience. What Swift did back for Apple is it cracked open the developer experience. It made it so, 10 times more people could be involved building apps. And so we saw this explosion of innovation in the App Store. Today, we have literally the same problem with CUDA. CUDA is a C++ derived language. It's 40 years old from the 80s. It's venerable. We love it. It works, but it's not something that anybody loves. And so what Modular is doing is both opening this box, fixing the language problem, fixing the platform problem, enabling both more developers to upskill and learn about this modern compute. Everybody should be a GPU programmer these days, and also give people choice. And so that those two sides of this, both enable the hardware to break through, enable more developers into the ecosystem are both the key parts of the mission.
And
Oh, go ahead, Matt.
no, please.
I wanted to actually change gears a little bit and just talk about the industry more holistically. We talk a lot about AI's reputation on this show, and it doesn't seem to be super positive right now, by and large in America. I'm curious if you agree with that, and have you identified why? Obviously there are leaders in AI who are calling for a white, or not calling for it, but saying that a white collar bloodbath is inevitable. I don't think anyone wants this. But there's a lot of fear and anxiety built into this
Absolutely.
right now. Yeah, what's your take on all of this?
Well, so I'll zoom into one quadrant of this is the software development side of it. Like we've seen in the last few months, AI coding just transform with the tools and the capabilities, and many of the programmers I speak to are just freaking out in various forms. I've been in dev tools for decades now. I've been an AI person for 10 years, working and like dedicated to AI for quite some time. And so what I see, and I agree with you, by the way, is there's a lot of hyperbolic claims, and they're coming from people selling the tools. It's coming from developers that want to make other people feel like they're falling back. I also see a lot of, pessimism, like, these tools are stupid. AI is ridiculous. Nobody should be using this, and blah, 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 blah. The claims are BS and they can't be true. And both sides are right in different amounts, but they're both so extreme, it's impossible to understand what's really going on. And so my take on this, and my take on AI in general, is, with the long-term view, AI is constantly changing. There's new breakthroughs that happen every week. It's incredible what the model of the day can do. But it's a tool. And what you need to do, what we all need to do, is we need to figure out how to best map these technical capabilities into a solution to a problem. And so with AI coding, for example, people are talking about, software engineering is dead. I don't know about that. Like, I do think there's going to be a lot more software in the world. That is certainly true. And I think that people are going to be more productive. But we're seeing jobs in software explode. We're seeing in like grow, right? And we're seeing, the amount of cool things that people are doing is just unlocking people's creativity. And so the question always, there's different ways to interpret the data, and we'll see what settles out. I think the only thing that we can know for certain is that people who ignore this will get left behind.
And Chris, so let's put it in the context of Modular then. Tell us, how big is your team? And then are you hiring right now? Are you hiring more software engineers? What does that the structure of your team look like as you're building out your company in the age of agentic coding?
Yeah, absolutely. So our company is just over 170 people at this point, and we are absolutely hiring like crazy. If you're into compiler systems, performance, inference, please reach out, check out our careers page. We have so much to do, and the opportunity is so vast. We're connected to the silicon. We're connected to enabling platforms. We're connected to developers. And when you look at the space of, hey, enable chips to go fast, enable them to actually work in a unified platform, there's a lot of chips out there. If you look at the scale and the pace and the frenetic nature of AI models and the innovation that's happening, there's every day there's new papers that come out. Like it's impossible to keep up with all this stuff, right? And so what we're trying to do is we're trying to be that integration point that helps factor it for the world. Because a lot of people on the enterprise side, they want the latest and greatest research. They want good TCO. They want good performance. They want a mature cloud platform. They don't want to be chasing the latest bugs and the latest thing that they download off the internet. They want something that's reliable so they can focus on their problems. And they also want choice. They want to be able to choose the best silicon for their workload. They want to get, not just have to switch to a different chip, but they want some of their workload on some chips, some of the workload on others. Right? That's what we help with.
Who is buying Modular? What is the ICP of the user of Modular?
Yeah, right now we're working with advanced like research labs and things like this primarily. We have a cloud platform. It's in beta. It will go generally available in roughly August. And so we are working with the people that generally they're at scale, they're generally suffering, generally they can't get enough compute. And so if you can get 40% better TCO, that's also 40% more Blackwell nodes and you don't have to procure. And if you're like renting nodes, it's also just way more scalable for you. And so we help people with these kinds of problems. As we grow into later this year, right, there's a lot of folks that come to us that just want to unify their inference platform, and they've got some, systems they've been building up over years and years and years and years, and they want everything to work, and they can't break everything, but they also want to have something that's easier to manage, scale, and deploy, while taking in the latest research, getting the best performance, getting access to the latest silicon.
I want to go back just very quickly to modular hiring. So we've been talking a lot about how the roles of the product manager and the engineer seem to be converging, where the engineer has to be not only focused on the quality of the code, what kind of products they're creating, what kind of features they're developing, but they have to be thinking about the higher level impact of their work and how it fits into the roadmap, how it impacts customers.
100%.
What is the profile that you're hiring for? Is it a traditional engineer, or are you looking for a completely different person these days?
Yeah, I wouldn't say it's a completely different engineer, but we definitely select for folks that are willing to learn and grow. So we hire juniors that are just coming out of school, for example. We hire senior experienced folks. They're deep experts in different areas. But if you're a deep expert and you're not interested in learning new things, then it's not going to work very well, right? We want growth mindset no matter how senior you are and what you're doing. What I'd say is that when you look at engineers, every engineer, even if you're fresh out of school, is now a manager. You have to bring that manager thinking because may have some agents working for you, right? But you have to think not just about like the lines of code, but you have to think about, as you say, the objective. What is the goal here? How do we interrelate with other people and other teams? How do we think about the long-term architecture of what we're doing? And I think this is actually quite interesting and challenging, but I think that the folks coming out of school are actually the best prepared for this, right? They've been living in this fast-moving world. They can adapt very quickly. They're not stuck on old ways. And so to a certain extent, they have superpowers that other folks kind of struggle with. Now, I see everybody's adapting and adopting and changing. And so some people are early on that curve, some are kind of further back on the S-tail, right? And I can't say there's one right answer for everybody. But if you're in our case, we're in deep systems and performance and low-level coding and things like this, right? It's a little bit different than if you're building a web app and you're building prototypes for people, right? And so for us, like it's about adopting the tools, it's about taking advantage of these things, but it's also about making sure you know how to use it the right way. I think that's really the key because sure, everybody wants to talk about one-shotting the, cool game or something, but that's not software. Software is product. Software is understanding the customer. Software is architecture. Software is working with other people. And so the writing of code got accelerated dramatically, but that's never actually been the bottleneck.
Yeah. Chris, it's so interesting to hear your perspective on this because I mean, I literally said it earlier in the show. We're hearing such a wide spectrum of opinions on hiring. You're saying the entry level folks straight out of college who are kind of born into this agentic coding era know it so well, are able to move and adopt very quickly. From others, we're hearing, no, we're pausing hiring. From others, we're hearing, no, we only want senior engineers because they're the ones who are going to be able to delegate to agents most effectively. What do you attribute this like wide variance between companies who, ultimately we're all building technology? What causes that variance?
Yeah. So, I mean, I can't give you the right answer, but my opinion is that you have multiple factors. So one is that these are actually different businesses, right? And so if there may actually be different right answers, air quotes, for different businesses depending on their constraints. But there's also a lot of people saying that soundbite that they think sounds good because they want to justify a layoff that should have happened a long time ago. It could be that they're doing, performance management or some other thing, and so they're using this as an excuse to cover for that. It could be that they actually don't know what they're doing. Right. So I think that a lot of very senior CEOs and things like this are making very sweeping claims because of headlines they read, but they don't really understand the nuts and bolts of software creation. And sometimes they'll end up regretting some of the decisions they made. For me, I think that the thing that I look for, and I can't say that it's true or correct, but the thing I look for is a balanced team. Like you don't want all generals, you don't want all troops. You need a balanced team where you get wisdom, experience, and the long-term view. You need folks that are eager to learn and grow and change and go, and you need that full spectrum. And I think that's always been true.
So software stocks took a hit recently. Some people attribute it to Anthropic's release. It was probably a culmination of things. I'm guessing, hearing you speak now, that you don't necessarily buy into that software has a little bit more longevity than the market's giving it credit for.
Yeah, well, so I mean, I think that when you look at software, and one of the things I'm seeing, and one of the things I predict a lot more of, is using AI tools to clone proprietary software. So in the LLVM community, there's a whole thing around chip design tools, and somebody used agentic coding stuff to go clone one of the proprietary tools for chip design, or a small part of it, and everybody's trying to figure out what does that mean, right? And nobody wants to get sued. There's like a whole thing going on. But the reality is that businesses are more than just their code. Businesses are also, the data they have, it's the customer relationships, it's the support contracts, it's much bigger than just the code. And so again, what you're doing is we're accelerating a part of the cycle of creating products and the iteration speed. We can figure out and discover new niches and get to PMF faster. That's all very, very true. And I don't think that's BS. But the folks that are saying software's dead, that's a little bit extreme, and we'll see. I haven't seen the data that shows that that's happened yet. I've seen the stock prices drop, which is kind of sentiment analysis for the market. But what we'll need to see is what happens with the revenues and what happens as these things go. Now, I think Anthropic expanding, like that's a different thing. Like they are a very capable team, and if they decide to enter a market, well, it could impact that one market potentially, right? But they'll have one product entering into an existing market, and it will have to prove itself and have to build into that full product journey.
Chris, as somebody who thinks about the overall architecture of software, like if you project out, do you see? I think I believe this. I don't think, but I've also heard a lot of other people say it, where basically all software is going to collapse down into an agentic layer, an agent layer, and then on top of basically a file system, some kind of database, a system of record, a file, right? So like, do you see software ultimately heading in that direction and consolidating around the agent layer, or is that overblown as well?
I Again, my take on it is that the agent layer is a new thing. It's a new category. Just like when cloud came in, it didn't like kill PCs or something, right? It is value accretive. It's capability accretive. It's a new thing. It will make sense and will be amazing for many workflows, for example. It's not going to impact home thermostats, right? And so I think that what people naturally do is there's a selection bias of when you look at a new technology coming onto the scene, people, particularly the ones pushing that technology, they really want to overclaim and over project the impact. And if you look at the rise of the internet and various others, or mobile, or these other cycles, like incredible value creation, incredible opportunities, definite winners and losers, right? The people that ignored it became obsolete in many cases if it was relevant to them. But it's not like everything's on a phone, right? Turns out a lot of stuff's happening in data centers, right? And so this is where, again, like I think that we need to tune into what's real. Like the overclaims, I think are very obvious, or at least many of them are. And so there's a middle path. And I think that the winners are the ones that understand that middle path and get past the hype, get past the hyperbole, and can actually map it well to their businesses, map it well to their opportunity, and figure out like, no, we're not just going to like throw ourselves into agents because somebody else is doing it. The dog food company, maybe that's not really what they need to do, right? But for the people that are on the cusp of like user experience and being able to offload things from humans, like yeah, absolutely, this is like a new form of software that is so key to a lot of user experiences.
All right. Well,
Thank you
Chris,
for the practical perspective. It's always
yeah.
refreshing to hear it.
Yeah, definitely. Chris, thank you so much for joining us today. You can find Chris on X at C_Lattner_LLVM and modular.com. And Modular is hiring. So if you're a fantastic software engineer, go apply to Modular. Chris, thank you so much.
Awesome. Thank you for having me.
Pleasure.
Thank you, Chris.
You.
Well,
Man, we had some heavy hitters on today's show.
Absolutely. That was a fun one.
Yeah. Yeah, super fascinating. I like having guests that have very differing opinions about the future of software, the future of the engineering culture, and landscape. So I'm really happy with how today's show came out. But thank you everybody who watched. That's our show for today. Nick, as always, thank you for co-hosting.
Of course, happy to do it.
And
we'll see you all next week.
Yeah, don't forget to check us out on Twitter at Forward Future. You can check out our new brand and forwardfuture.ai. Thanks to the guests. Thanks for everybody who watched. We'll see you next week.